Tinkercad software. Then how you design the circuit? By using Tinkercad. Here series circuit. Series means there is end-to-end connection. Now this is the resistor. Its value is 1 kilo ohm. The resistance value is 1 kilo ohm. Then here is one capacitor. This is a non-polarized capacitor. This is non-polarized capacitor. Okay. Series circuit, and your input is given this point. Which input? Sinusoidal, triangle, square signal. And the capacitance value is that is 0.1 microfarad. 0.1 microfarad. Then how you give the signal to the circuit? You give the signal from function generator or signal generator. This is function generator. Function generator. Then how you got the output? You got the output through oscilloscope. Here you connect. That is oscilloscope. Here you got the output. The integrator circuit, when you give the sinusoidal signal, then what is your output? Now you tell, if your signal is sine, then what is your output? In the integration, what is the integration of sine signal? Cos. Cos or minus cos?
Minus cos.
Minus cos.
Actually you got like this. And when you give the square signal, then what is your output? This is a square signal. Then what is your output? In integration. Now you check the formula, that is output. This is the integration. 1 by RC, that is B in T dt. Integration of B in T dt. Okay. The integration of square signal is triangle here. Like this signal. This one. Triangular signal. You got the triangle signal. And when you give the triangle signal, then what is your output? That is parabolic signal. Or it looks like a sinusoidal signal. Parabolic. Or it will look like a sinusoidal signal. Okay. First you design the circuit by using Tinkercad. Then after that you give some signals like a sinusoidal, triangle and square signal. Then you just take the output. What is your output? Okay. Then which signal you got in the output. Here now you see the observation table. This is the procedure. Integration in the integrator, circuit shown in the figure 1, function generator. Amplitude is 10 volt peak to peak and the frequency is 200 Hz. Square waveform input, square waveform, connect channel 1. Now you see the observation table. This observation table for high pass filter and low pass filter. Now you see, this is the integration in the integrator. When you give the 200 Hz square signal, then what is your output signal? This is your input signal. Frequency is 200 Hz. The amplitude is 10 volt peak to peak. Here there is 10 volt peak to peak amplitude. First you give the 10 volt, voltage is 10, amplitude is 10 volt and frequency is 200 Hz square signal is given to the integrated circuit. Then after that, which signal in your output? Here just you draw in triangle. Then after that, just you increase the frequency. That means you give the 20 kHz square signal to the circuit. Then here the which signal in your output? You draw in triangle. Here is the same 20 kHz sinusoidal and 20 kHz triangle signal. Then the second case, the differentiator, you design the differentiator circuit by using Tinkercad. Then after that, you give the 20 kHz square signal, amplitude is same 10 volt peak to peak. You give the 20 kilohertz square signal to the circuit, then what is your output signal? Here again 200 hertz square signal 200 hertz. What is your output? Now I design a circuit. One example. Okay, now you see the figure. One resistor, then another is capacitor connected in series. This point is one. This is positive terminal, and this side is negative. This is positive of the function generator. This side is negative of the function generator. And this side is also negative. Negative, negative. This is 1 kilo ohm resistor, 0.1 microfarad capacitor, non-polarized capacitor. This resistor and capacitor both are connected in series. Both are connected in series. Now, you take one breadboard. Why you take breadboard? Because your design circuit is easy. Your circuit is easy to design by using breadboard. Now here breadboard. In the breadboard, these holes are vertically same potential, and the upper two lines, that is minus and plus, this is horizontal same. Okay. The breadboard. Now another component is that resistor. Click on the resistor, then after that go to the rotate. Then you take a non-polarized capacitor. Non-polarized capacitor connected in series. Now this is series connection. That is end-to-end connection. Series connection. Now your input is this point. Input terminal number 1, and this side is terminal number 2 of resistor. Your input is given to the terminal number 1 of the resistor, and this all holes are terminal number 1 of resistor, and this side is terminal number 2 of capacitor. Then the negative is given to the terminal 2 of capacitor. So now just I take one function generator. You write here function generator function. Then you take two oscilloscope. Now why two oscilloscope? Now in the Tinker card, the oscilloscope is a one channel oscilloscope, single channel oscilloscope. Single channel means you see only the output, either output or input. Either input or output. That's why you take two oscilloscope. Two oscilloscope means one oscilloscope you see the input signal, then another oscilloscope you see the output signal. This oscilloscope, then you take another oscilloscope. And now just naming. And this oscilloscope is output. You write output. And this oscilloscope is input. Input signal. And this is function generator. Function generator. function generator. Now first you generate a square signal. The procedure is in integrator circuit. Switch on the function generator, set the amplitude 10 volt, peak to peak, frequency is 200 hertz square wave. 200 hertz square wave. Now you give the 200 hertz square wave. Now you connect positive to positive, positive to positive, and negative to negative. Negative to negative. Here is 10 volt. You give the 10 volt peak to peak. Frequency is 200 hertz. Here you write 200 hertz. 200. Offset voltage is always 0. And signal is a square signal. And here you change the time period. You take 1 millisecond. Both cases you take 1 millisecond. Now start simulation. Now you got the square signal here. Now you see you got the square signal. And this square signal is given to the circuit. Stop simulation. Here is positive. Positive is connected to the positive terminal number 1 of the resistor. Otherwise you give now I give the positive here. Okay. That means all holes are positive. All holes are positive. Now I give the negative same. Now I give the upper holes. That is all the upper holes are negative. Now negative. Okay. Now positive is given. Positive terminal. Here is terminal number 1 of the resistor is positive. This is the positive. And this side is we connect negative. This is the negative and the negative connected is here. And your output positive terminal where the resistor and capacitor both are connected. That is your positive of the output. And the negative, then all the negative are connected in a same point. Now I connected here, all are the negative connected here this point. Okay. Now start simulation. When this is your integrated circuit, when you give the 200 hertz square signal to the circuit, then your output will be same. You got the same signal, same square signal. But when you give the 20 kilohertz, change the input frequency 20 kilohertz, then the plot the graph and input and output waveform. Now here you give the 20 kilohertz frequency. Just click on the function generator and the 200 hertz just you change and you write 20 kilohertz. Then what is your output? Now you see. Then you again change the time per division. You take 0.1 millisecond. In the high frequency case, you change the time division. Now this is the square signal or 0.01. Now you see, this is the integrated circuit. This is the integrated circuit. When you give the square signal, 20 kilohertz square signal, your output will be, that is triangular. Now this is the integrated circuit. Integrated circuit. And when you give the triangle signal, this is the parabolic, or it looks like the sinusoidal signal. Now the signal change. Input is square, output is sinusoidal. It looks like sinusoidal signal. And when you give the sinusoidal signal, actually your output will be what? That is minus cos signal, but here both signals are equal. Why? Now this is a single channel oscilloscope. Single channel oscilloscope. If you take the dual channel oscilloscope, in that case you check your input is sinusoidal and your output will be changed. Output will be changed. But this is a single channel oscilloscope, that's why you don't see the minus cos signal here. And another thing, you see the input voltage. What is your input voltage? The square signal, what is your input signal voltage? Total voltage is 20 volt already written. Then how many blocks? That is 10 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That total is 10 blocks. Then each block is 2. Each block is 2. Then how much division cover in the above the axis and how much division lower the axis? Now you calculate one big block, another big block, then another half. Another half. That means 2, 2, 4, 5. Half means that is 1, 5. A lower case same. One big block, another big block, that is 2, 2, 4, then another half. Half means that is 1. Why 1? Then one block is 2 volt. Then half of the block is 1 volt. Total is 10 volt. Lower side is 5 and the upper side is the 5 volt. That is total is 10 volt, 50 volt. Okay. In the same, the output case, what is your voltage? Output is what is your voltage? Here is 2 volt. Total is 2. So each block is 0.2. Each block is 0.2 volt. Then now you calculate what is your voltage, what is your amplitude? 1, 2, 3, 4, 5, 6. It covers 6 blocks. 6 block means that is 6 into 0.2. That is 1.2 volt. The output amplitude will be 1.2 volt. This is the integrator circuit. The observation table here, the square 200 Hz, your output signal is same, square signal, you draw in freehand and you mention the voltage. Here is 1.5 volt. Amplitude is, here in the signal that is 5 volt, but you give the 10 volt. Right? You give the 10 volt. That is 0, minus 5, lower side is minus 5 and upper side is plus 5. Plus 5. And here same 20 kilohertz. What is your output signal? Output signal is triangle signal. Then what is your voltage? You mention here. What is your voltage? That is 1.2 volt means plus of 0.6 above the axis is 0.6. This 0.6 and the lower the axis is 0.6. 20 kilohertz is same. This is the integrator circuit. And the differentiator circuit, just you remove. Just the differentiator circuit, what will you do? Now just you change the components. First, now I remove the resistor here. I remove the resistor, both resistor and capacitor. Then in the resistor, I fix a capacitor. I remove the resistor and fix a capacitor. And same, remove the capacitor and fix a resistor. This is 1 kilo ohm resistor, same 0.1 microfarad capacitor. Now the design circuit. Here is what is the capacitance value, 100 microfarad or fix your micro. Then just I interchange the components here. Now this is the and this output where the resistor and capacitor both are connected, and that terminal is your positive output positive terminal. Now this is the differentiator circuit. This is the differentiator circuit. In the differentiator circuit, when you give the 20 kilohertz square signal, 20 kilohertz square signal, your output will be same. 20 kilo output will be same. Square signal. But when you give the 200 hertz signal, then what is your output? Now you check. When you give the 200 hertz frequency, and here 1 millisecond. So sir, 1 millisecond. Now you see, this is the square signal, and your output will be spike signal. When you give the square signal to the differentiator circuit, your output will be spike. This is the spike signal. And when you give the triangle signal, this is square signal, and it is not correct, but you consider this is a square signal. This is the square signal, and when you give the sign, that is cos. But here is no cos, same signal. Why? Now this is a single channel oscilloscope. If you take the dual channel oscilloscope, in that oscilloscope you see the both in sinusoidal and cos signal. This is the differentiator circuit. This is the differentiator circuit. In the same, the differentiator circuit, your input is the same, 10 volt. Then you calculate the output voltage. Here is 2 volt. Each block is 2.2. And how much division cover? The y-axis 1, 2, 3, 4, 5, 6, 7. 6 means 6.2. That is 1.2 volt. This is your integrated circuit and the differentiated circuit. Okay, now any doubt in differentiated integrated circuit, then you ask me.
Sir, can you explain how are you making the breadboard connections?
Okay. Now I remove all the components. The bad internet. Okay, now you see, this is the front side of the breadboard, and this is the back side of the breadboard. Okay. The just you mark here plus and minus. The plus means that is total holes are horizontally same potential and same voltage. Same voltage. Here you just you see the arrow mark, upper arrow mark. That is internally connected, horizontally internally connected, plus or minus. And the ABCDE, FGHIJ. Okay, ABCDE. This is separate. This is another vertical same potential, internally connected, vertical internally connected. Then another side is same FGHIJ. This is another side, vertically internally connected. And when this is the holes, it is 30 holes up to 30 negative. When you give the negative voltage to the pin number 1, then you got the same negative voltage, that is pin number 30. Okay, that is internally connected. And when you give the positive voltage to the pin number 1, then you got the same positive voltage, pin number 30, that is internally connected, horizontally internally connected. And here is that is vertically, that's 4 holes like this. That is 5 holes. A, B, C, D, E. And another is F, G, H, I. A, B, C, D, E. And that is series connection means that is end-to-end connection. This is a resistor and this is a capacitor. This is series connection. Terminal number 1 of resistor, terminal 2 of resistor. Terminal number 1 of capacitor, terminal 2 of capacitor. This is series connection. Series connection means that is end-to-end connection. Now how you connect? This point you connect here. I take a one resistor. This is the resistor. A1, terminal number 1 and terminal 2. Okay, the capacitor terminal number 1 connected with the terminal 2 of resistor. Here, this is the capacitor. Terminal number 1 of the capacitor connected with the terminal number 2 of resistor, and another is 2 of capacitor. Then, where the resistor and capacitor both are connected, that is your output positive. This is positive of the output. And another side of the capacitor, that is terminal 2, is negative. And here you connect a one oscilloscope. Output. And the input is given from signal generator. This is your positive. And negative, you connected all the negative terminal. You connected the same potential. This is the terminal 2 of capacitor. That means these holes are now negative. That means this negative you connected here. This is input. This is output. This is the series connection. Resistor and capacitor. This is the physically breadboard. Front side and this is the back side. The same, the figure now, resistor and capacitor both are connected in series. Just you take a one resistor here. Just rotate. Now this side is terminal number 1 and this side is terminal number 2. Okay. Now you take one capacitor. This is a non-polarized capacitor. the terminal number 1 of capacitor here, terminal number 1 and terminal number 2. Terminal number 1 of capacitor connected with the terminal 2 of resistor. Just here. Now both are connected in the same potential. Okay. Then this terminal you connect to the negative of the function generator, and this terminal you connect positive of the function generator. The function generator where you connect positive here connected and negative. And oscilloscope same. Oscilloscope, one oscilloscope for input, another of the positive to positive you connect, positive to positive, negative to negative. Negative to negative. And where the resistor and capacitor both are connected, that is positive. Output positive here. And another is negative terminal here. Direct. Easy experiment. Now you change the time period. You take 1 millisecond. When you give the low frequency signal, in that case you take 1 millisecond time period. 20 kilohertz signal. So voltage is 10. When you give high frequency, then you take 0.01 millisecond. And 1 microfarad or 1 microfarad. This is your indicator. Now you understood about breadboard. Hello.
Yes, sir.
Yes, sir.
Sir.
Okay, this is the integrator circuit, and decreasing the differential circuit just to integrate the components. Then you got the integrator. In integrator step, you give the small frequency signal. Then you check the output. Check the output. And when you submit your record, then this figure will be attached in your player copy. Then how you attach? Now just you take a print screenshot. Okay. In your laptop, just you click or just to press the print screen. There's the print screen button. Then just you open the Microsoft Word and here integrated circuit square signal, and this is your output signal, triangle signal.
Sir, can you please explain how do you rotate the register?
Okay, just click on the stop simulation, click on the register. Okay, click on the register, then after that here rotate option. The left side, rotate already written, rotate.
Yes, sir, got it.
Yes, rotate. And this is about your differentiator and integrator circuit. And in the observation table here, you fill up and you draw in Prion. You draw in Prion. Square signal 200 Hz, you got the same signal. 200 hertz signal. Voltage is the same. But when you give the 20 kilohertz, what is your output signal and what is your voltage, output voltage? You mention here. But you draw in freehand. You waveform, you draw in freehand. But you mention the output voltage. What is your peak to peak output voltage? You mention. And waveform also. And similarly, the high pass filter and low pass filter. This is the observation table for high pass filter and low pass filter. Actually, here you draw two observation tables. One observation table for high pass filter, then another observation table for low pass filter. Filter means which rejected the unwanted signal or unwanted frequency signals. That is known as filter. Which reject the unwanted frequency signals, that is known as filter. So different types of filter: high pass filter, low pass filter, band stop filter, band reject filter. But here we discuss only the high pass filter and low pass filter. High pass filter, low pass filter. Filter means which rejects the unwanted frequency signal, that is filter. Okay. Low pass filter means which passes only the low frequency signal and rejects the high frequency signal. That is known as low pass filter. That means in the low pass filter only low frequency signals are passed. And same in the high pass filter only the high frequency signals are passed. And your low frequency signals are not passed. But in the low pass filter high frequency signals are not passed. But low frequency signals are passed in the low pass filter. Then similarly you design the circuit by using Tinker card here. Same circuit. This is the integrated circuit and it is known as your low pass filter circuit. In the low pass filter circuit you give the sinusoidal signal. Now you give the sinusoidal signal. Here sinusoidal signal. And what is the frequency? Now you see the observation table. B in 2 volt peak to peak. 2 volt. Okay. What is your voltage? That's 2 volt. 2 volt. Starting frequency is how much? 100 hertz. 100 hertz. 100 hertz. Huh? This is the low frequency signal. Then you change the time period. You take 1 millisecond, both cases. 1 millisecond. Here, frequency is 100 hertz. Input voltage is constant, 2 volt. Then what is your output voltage? That means when you give the 100 hertz frequency, what is your output voltage? And when you the 200 hertz frequency, what is your output? 500 or 1 kilohertz, 1.1 kilohertz up to 100 kilohertz. You calculate only the output voltage, not input voltage. Why? Na input voltage is always constant. Then after that you calculate the gain. That is, what is the gain? The gain is converted into dB range. That is 20 log base 10 output by input. Input is 2 volt. Then what is your output? Now one example, 100 hertz frequency. This is the low pass filter. Okay. Now I give the 100 hertz frequency to the input signal. The input signal now you mark here. What is your input voltage? 4 volt. Then total block is 10. Then each block is 0.4. Each block is 0.4. Now how much division cover in y-axis? 2 big block and half of the 1 big block. That is 4 means that's 0.2. 0.2. That is 0.4, 0.4, 0.8, and this is 0.4, this is 0.2. 0.4, 0.4, 0.8, this is 0.2. That is 1 volt. And upper side is the same. 0.4, 0.4 is 0.8 and half of the another block, that is 0.2. That is 2 volt. Okay. And in the output side now you calculate here. 4 volt. Each block is 0.4 volt. 0.4. It covers 1, 2, 3, 4, 5 blocks. 5 blocks. 5 block means that is 5 into 0.4. That is 2. When here this is frequency, this is V out and gain, that is a V. ये 20 log base 10 out by input. V out by V in. V in always 2 volt. Okay. Then when 100 hertz, what is your output voltage? 2 volt. Then 200 hertz, what is your output voltage? You calculate only the output. Now I give the 200 hertz here. Then what is your output? Output is same. Same. 2 volt. Okay. And here you write 2 volt. Now suppose I give the 1 kilohertz. Here 1 kilohertz. What is your output voltage? Okay. Now you see, change the time period, otherwise clearly visible. Now when you give the 1 kilohertz signal, then your output will be same, no change, output is same, 2 volt. Here is 4, then each block is 0.4, that is 0.4, 0.4, 0.8, 0.2, 1 volt, and the lower upper side is 1 volt, that is 2 volt. Now what is your output voltage? In the output voltage you mark here. Here is 2 volt. Here is 2 volt. Then total block is 2. Then each block is 0.2. Each block is 0.2. Then how much division cover in y-axis? 1, 2, 3, 4, 5, 6, 7, 8. This is 8 block. Then 8 into 0.2. That is 1.6 volt. Here, when you give the 1 kilohertz, your output will be 1.6 volt. Okay. And similarly, when you suppose 50 kilohertz, example, okay, we give the 50 kilohertz. And you change the time period. Here, now you mark here input. Input is the same, no change in input. 4 volt. Then 0.4, 1, 2, 3, 4, 5, same. And what is your output here? What is your output? Here is 100 millivolt. Here is 100 millivolt. In the 100 millivolt, then each block is 1 volt. 10 millivolt. Each block is 10 millivolt. Then how much voltage? Suppose you consider half. This is half and this is half. Here 1, 2, 3, 4, 5. That is 50 millivolt. Another 50 millivolt. Another 5. Another 5. 60 millivolt. 60 millivolt. When you give the 50 kilohertz frequency, you reach 60 millivolt. Now you calculate the gain 20 log base 10 V out by V in. Here is 2 volt, output is 2, input is 2. That is 1. 20 log base 10, 1 is 0. Same 200 hertz, 2 volt output, input is 2 volt. That is 1. Gain is 0. This here is 1.6. Then 1.6 by 2. Then what is the value? 1.6 by 2. This is 0.8. The 20 log base 10, 0.8. What is the value? 20. Okay, 20 log base 10, the 1.6, that is the 0.8 means that is the minus 1.9 volt. Sorry, minus 1.9. That gain is minus 1.9 like this. Okay, you got the negative value. You got the negative value. And this value you just plot in a similar paper, not a graph paper. Okay, are you know about similar paper? Similar paper.
No, sir.
All of you know about
No,
graph
sir.
paper, huh? Okay,
Yes,
graph.
sir. Yes, sir.
Okay,
Yes,
graph
sir.
you know, but you don't know about similar paper. Similar paper means just you plot the logarithmic value, and your similar paper is like this. Uh, now see, this is the similar paper. Yes. The similar paper this is the similar paper. In the similar paper already written some value, some number here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again 1. 2, 3, 4, 5, 6, 7, 8, 9. Again 1. Again 2, 3, 4, 5, 6. Again 1 like that. Okay, 1 means your starting frequency is 100 hertz. Starting frequency is 100 hertz. Now 1 means you consider 100 hertz. Then 200. 2 means 200. 3 means 300. 4 means 400. 500, 6, 7, 8, 900. Then after that 1 kilohertz. 1 kilohertz. Okay. 1 kilohertz, then 2 kilohertz. 3 kilohertz, 4 kilohertz, 5, 6, 7, 8, 9, 10 kilohertz. Then after that 10, then after that 20, 30, 40, 50, 60, 70, 80, 90, and last one is the 100 kilohertz. The starting frequency is 100 hertz, 200, 300, 4, 5, 6, 7, 8, 900, then 1 kilohertz, 2 kilohertz, 3 kilohertz, 4, 5, 6, 7, 8, 9 kilohertz, then 10 kilohertz, then after that 20, 30, 40, 50, 60, 70, 80, 90, and 100 kilohertz. This is your frequency axis, and y-axis you take your gain in a dB. Gain in a dB. This is 100 hertz, that is frequency, gain in dB is 0. You plot frequency and logarithmic value. This one and this column and this column. ये नहीं, not this. Okay. Frequency versus gain, that is the logarithmic value. Frequency versus logarithmic value. Okay. Now, here is your similar paper. This is similar paper. In the similar paper, already mentioned here like this. You take two similar paper. Now, why two similar paper? One similar paper you plot the high pass filter, then another similar paper you plot the low pass filter. Low pass filter. Okay, suppose like this. And this axis you take gain in a dB, that is gain in a dB. Just you write gain in dB. The starting dB is 0, then -5, then or -15, -20, -25, like that, or -20. Okay, and this is this में होगा. Okay, this 5. Suppose this. Now I just labeling. This is the similar paper. Starting is 1. Okay. Starting is 1. ये 1, 1, 2, 3. 100 hertz, 200, 300, 400, 500, 6, 7, 8, to 100 kilohertz. ये 100 kilohertz. 100 kilohertz. Okay, this is 100, 200, 300, 400, and then up to 100 kilohertz. Okay. When frequency is 100 hertz, what is your gain? When frequency is 100 hertz, your gain is 0. Gain is 0. This is 0. Just you mark and just draw a circle. And when 200 hertz, gain is also 0. 300 hertz, gain 0. 400 hertz, gain 0, or 500 hertz. One example, gain 0. But when you give the 1 kilohertz, when you, what is your gain? That is, gain is minus 1.9. Okay, this is 0, and this line is minus 1. Minus 1.9. 1.9 means that is this. And when is 50 kilohertz? Now go to the last point. Suppose when your frequency is 50 kilohertz, your gain is, suppose, one example, 30 or minus 25. Here is minus 25. And 100 kilohertz, that is minus 40. This is 30, and the last one is suppose minus 40. And when 100 kilohertz, your is minus 40. This one. And your graph is like this, constant, that is in the straight line, constant, then decrease, like this, decrease, then decrease, then decrease, decrease, and decrease like this. This is for low pass filter graph. The similar paper, you plot the low pass filter graph in the similar paper. Okay. This is the low pass filter graph. Then after that, you calculate their cutoff frequency, FC, cutoff frequency. And how you calculate the cutoff frequency? Now, the cutoff frequency range is, that is minus 3 dB. Minus 3 dB. Here is minus 5. between the 0 and -5, then you take -3 dB range, -3 dB. All are the dB. Gain is in dB range, -3 dB. Then just you in the -3 dB, just you draw a line, and where it touches, that is your cutoff frequency. Suppose this line, suppose cut. This is the cutoff frequency. This is 1 kilohertz, and between 1 and 2 kilohertz. Suppose here is 1.5 suppose, and your cutoff frequency is 1.5 kilohertz. This is your low pass filter observation. Graph. This is the low pass filter. The high pass filter case, same, gradually increase. Then after that constant. The same -3 dB where it touches.
Sir, how are we deciding -3 dB?
Okay, the -3 dB means that is your audio frequency range. Audio frequency range, that is 20 hertz to 20 kilohertz. That is -3 dB range is your what? That is audio frequency gain. That's why we decide that is -3 dB. That is audio frequency gain.
Okay, sir.
That's our actual audio frequency how much? Audio frequency 20 hertz to 20 kilohertz. Less than 20 hertz, we did not listen any information or any sound. Then after 20 kilohertz, that is bigger sound. Maybe our ear, maybe damaged. In that case, that is we take our particular gain, that is -3 dB. That is the dB means decibel. अगर 3 डेसिबल से ज्यादा हो जाएगा तो शायद हमारा जो ईयर है इनके अंदर में एक उसको क्या बोलते हैं डाइफागाम क्या है, उसके अंदर जो है वो में भी डैमेज हो सकता है। और -3 dB डेसिबल से अगर लो हो गया तो हमको कुछ सुनाई नहीं देगा, हम कुछ नहीं सुन पाएंगे। इसलिए वी कंसीडर दैट इज -3 dB द्वारा ऑडिबल फ्रीक्वेंसी gain, audible gain. Clear?
Yes, sir.
Okay. Actually, here you plot two graphs. One graph for high pass filter, then another graph for low pass filter.
In the same paper.
No, not same paper. You take two similar paper. In the one similar paper, you plot high pass filter, and the second similar paper, you draw the low pass filter. The same, this is the high pass filter. The circuit, ये तुम्हारा हाई पास लो पास फिल्टर है, and the high pass filter case, what will you do? Just you interchange component. This one is now your high pass filter. The high pass filter means only your gain 0 means now your signals are passive. Gain 0 means signals are passive. That means in the low pass filter, when you give the low frequency signals, your gain is 0. That means that signals are passive. And here also, when you give the high frequency signal, your gain is 0. Now, this is negative. Now your output, just I connect this terminal. Okay. This is high pass filter. Now run. Now you see what is your frequency? 50 kilohertz. Frequency is 50 kilohertz. And your input voltage is 2 volt. Input voltage is 2 volt, peak to peak. 4 volt, each block is 0.4. 2 volt. Now, you calculate what is your output voltage. Output voltage is now same 2 volt. Now output voltage is 2 volt. 4 volt, then each block is 0.4. 0.4 upper side, that is 2.5, okay, 2.5 into 0.4. No, sorry, 1.5, no? 1, 1, 2, 2.5. 2 big block and half block. Lower side is the same, 2 big block, another is half block. That is each block is 0.4, 0.4, 0.4, 0.8 and 0.2, 1, and lower side is 1, that is 2. When you give the low frequency, high frequency signal, your gain is 0. Here gain is 0. Now I give the 100 kilohertz. Just you calculate the output voltage, not input. Input voltage is same. Here you just see here. Now you see here, there is 4. Approximately same. Now, suppose I give the 10 kilohertz. And what is your output? Same. 10 kilohertz, same volt, same 2 volt input. Now I give the 100 hertz frequency. What is your voltage? When you give the 100 hertz frequency, your input voltage is 2 volt. Okay. Then what is your output voltage? Here is 200 millivolts. That is 200 millivolt. Then each block is 20 millivolt. Each block is 20 millivolt. Then how many blocks cover? 1, 2, 3, 4, 5, 6. 6 into 20, that is 120 millivolt. When frequency is output voltage is 120 millivolt. That means in the high frequency, high pass filter, when you give the high frequency signal, your gain is 0. That means that signal are passive. But when you give the low frequency signal to the high pass filter circuit, then you got the some voltage means, or you got the some negative value. You got some negative value. That means that signals are not passes in the high pass filter. That is all about your high pass filter and low pass filter. Okay, now any doubt? You ask me. That is all about your RC series circuit, differentiated integrated and high pass filter and low pass filter.
Principle of working behind it means why it is allowing some signal to pass and some not to pass.
Yeah, high pass filter, filter, water filter.
Yes, sir.
What is the function?
Sir, it filters the impurities from water.
Yes,
And
that means you got the pure water. You got the pure water.
yes, sir.
Here it is same. Suppose in the amplitude modulation, in electronical language, actually the definition of filter is which is reject the unwanted signal in the electronic language. Okay. Here, suppose in amplitude modulation and demodulation. The demodulation part, basically you use the low pass filter. Amplitude modulation, one example, amplitude modulation or frequency modulation. Frequency modulation, all of you know what done by FM. That is FM radio. Okay. Then how you listening the FM signal? in your mobile or in your radio. In that case, one baseband signal, another is your module carrier signal. Baseband signal, carrier signal. Baseband signal means that is low frequency signal. Its frequency is very low. That is baseband signal. And the carrier signal means which carry the baseband signal. That is carrier signal. Okay, which carry the baseband signal. That is carrier signal. Now you mix both the signal, baseband signal and carrier signal. Okay, then you got the frequency modulated signal. Okay. Then how you listening the frequency signal, FM signal? FM signal means that is demodulated signal. That is demodulated signal. Demodulated means we use one low pass filter. Low pass filter means just the low pass filter separate the carrier signal. Carrier signal. Are you understood?
Yes, sir,
Baseband
yes.
signal. Listen. One is your baseband signal here. इसका फंक्शन डिफरेंट से यूज होता है. हाई पास फिल्टर हो, लो पास फिल्टर हो, बैंड स्टॉप और बैंड स्टॉप मीन्स पर्टिकुलर फ्रीक्वेंसी. अभी देखो ये दिस इज योर लो पास फिल्टर एंड अनदर इज and another is high pass filter. Okay, only high frequency signal pass and this is the only low frequency signals pass. Another is band stop filter. Band frequency are passes like this. ये पास नहीं होगा, दिस हाई फ्रीक्वेंसी लो फ्रीक्वेंसी पास नहीं होगा कि हाई फ्रीक्वेंसी पास नहीं होगा, इसके पर्टिकुलर फ्रीक्वेंसी पास होगा. ठीक है, अभी क्या है ना, जो फिल्टर है, सपोज इन द एफएम दिस इज बेसबैंड सिग्नल, अनदर इज कैरियर सिग्नल. दोनों को मिक्स कर दो. दोनों को मिक्स करने के बाद तुमको जो मिलेगा दैट इज एफएम सिग्नल, फ्रीक्वेंसी मॉड्यूलेटेड सिग्नल. ठीक है, फ्रीक्वेंसी मॉड्यूलेटेड सिग्नल. एक्चुअली ये दोनों को मल्टीप्लाई करने के बाद तुमको जो मिलेगा दैट इज फ्रीक्वेंसी मॉड्यूलेटेड सिग्नल. बट how you listening the music or FM, that is your demodulated signal. That is your demodulated frequency demodulated signal. अभी क्या है ना, वन लो पास फिल्टर यूज होता है इसमें, कैरियर को बेसबैंड से अलग करने के लिए जो फिल्टर यूज होता है दैट इज लो पास फिल्टर. लो पास फिल्टर मीन्स ओनली लो फ्रीक्वेंसी सिग्नल आर पासेस. कैरियर सिग्नल का जो फ्रीक्वेंसी है ये ज्यादा है और बेसबैंड का जो और मॉड्यूलेटिंग का सिग्नल का जो फ्रीक्वेंसी है वो बहुत कम है. अगर यहाँ पे हम लो फ्रीक्वेंसी सिग्नल लो पास फिल्टर यूज करेंगे तो ओनली ये पास होगा, लो फ्रीक्वेंसी सिग्नल पास होगा. दैट इज योर बेसबैंड सिग्नल. दैट इज योर बेसबैंड सिग्नल. देन you listening the music or FM, not music, that is FM हो या AM जो भी है, इसलिए हम लो पास फिल्टर यूज करते हैं और डीमॉड्यूलेट करने के लिए. एम हो, एफएम एम्पलीट्यूड मॉड्यूलेटेड हो या एफएम डीमॉड्यूलेटेड हो, इसलिए हम लो पास फिल्टर यूज करते हैं. आर यू अंडरस्टूड?
Yes, sir.
Stop presenting. Okay, any other doubt? पूछो, नहीं तो
Sir, have you to write this in practical book?
ना, एक्चुअली मैंने भूल गया है. तुम्हारा एक्चुअली फर्स्ट एक्सपेरिमेंट तो सबमिट नहीं किया है ना तुमने?
नहीं सर.
तुम्हारा नेक्स्ट वीक एग्जाम होगा ना?
Yes, sir.
Yes sir, mid-sem exams.
Mid-sem exam है.
Yes, sir.
ठीक है, then after mid-sem exam, then you submit both the experiment. Experiment
Yes,
1
sir.
and experiment 2. Okay. अच्छा, मैंने शायद
Yes, sir.
नहीं दिया. नहीं मैंने नहीं दिया मेरे को क्लास हुआ. ठीक है, मैं आज दे दूंगा. And listen, the second experiment, you write the procedure and observation. Observation already given in the manual. और उसमें क्या होगा ना, you take a screenshot, then after that you paste in the word file, and after that you attach in your share copy. और कुछ डाउट है? ये तो मिड सेम एग्जाम कब हो? मिड सेम एग्जाम कब हो रहा है?
Sir, from 9 to 11.
9 to 11, 9 February to 11 February.
तो नेक्स्ट फ्राइडे को तुम्हारा क्लास नहीं होगा?
Yes, sir. Wednesday to Friday, no class.
Okay, then you will try after midsem you will try to submit your record, that is first and second experiment, both experiments.
Sir, the observation and procedure that all we have to write in practical book. No?
हाँ, yes. नहीं, फर्स्ट एक्सपेरिमेंट का तो ऑब्जर्वेशन प्रोसीड्यूर तो लिखने की कोई जरूरत नहीं है. No need
The
of
first
write
experiment only had observations. No.
Yes. Only observation, no need of write procedure. But this experiment you write everything, that is procedure. थ्योरी तुम्हारा मैनुअल में है, वो लिख सकते हो, ठीक है. प्रोसीड्यूर भी मैनुअल में है. एंड ऑब्जर्वेशन पार्ट, ऑब्जर्वेशन में तो है तुम्हारा ये तुम्हारा ऑब्जर्वेशन है. ये ऑब्जर्वेशन फॉर हाई पास. एक्चुअली यू ड्रॉ टू ऑब्जर्वेशन टेबल, वन ऑब्जर्वेशन फॉर हाई पास फिल्टर एंड अनदर ऑब्जर्वेशन टेबल फॉर लो पास फिल्टर. ये दो ड्रा करना है तुमको, लेकिन मैनुअल में एक ही है, तुमको दो ड्रा करना है, ठीक है, ऑब्जर्वेशन टेबल. और ये तो है फिलअप करना है तुमको. इंटीग्रेटर फ्री हैंड में ड्रा करना है इसमें. स्क्वायर 200 हर्ट्ज, व्हाट इज योर आउटपुट सिग्नल एंड व्हाट इज द एम्पलीट्यूड.
Sir,
हाँ, यस.
sir, integrator is like the other name of low pass filter.
नहीं, नो. Integrated circuit and low pass filter circuit both are equal. Okay, that is
Yes,
similar, but not tell that is integrated circuit is a high low pass filter circuit. अब इंटीग्रेशन कब होता है? When you give the high frequency signal, then after that your signal will be integrated. लो सिग्नल में इंटीग्रेशन नहीं होता है कि नहीं? अरे जब
Yes,
तुम लो फ्रीक्वेंसी सिग्नल दे रही हो लो पास फिल्टर को, अभी देखो ये तुम्हारा हाई पास फिल्टर है, ठीक है, हाई पास फिल्टर है, ठीक है, ये हाई पास फिल्टर है. अभी दिस इज योर व्हाट डिफरेंशिएटर सर्किट. ओके, बट व्हेन आई गिव द दिस इज हाई पास फिल्टर मींस ओनली हाई फ्रीक्वेंसी सिग्नल चार पास है, लो फ्रीक्वेंसी सिग्नल पास नहीं होगा, ओनली हाई फ्रीक्वेंसी सिग्नल पास होगा, ठीक है. Now I give the square signal, low frequency square signal, 200 hertz. Amplitude suppose 15. That simulation अभी देखो, no, ये चेंज हो रहा है, ठीक है. When you give the low frequency signal to the differentiated circuit, then you got the differentiation of square signal. But when you give the high frequency signal here, there is no change. There is no change. तुम कह नहीं सकते कि हाई पास फिल्टर इज इक्वल टू इंटीग्रेटेड सर्किट. देखो अभी ये सिग्नल चेंज नहीं हो रहा है, बोथ आर इक्वल सिग्नल. Both are equal. Okay, now you understood. अभी देखो हाई पास फिल्टर में क्या है ना, ओनली हाई फ्रीक्वेंसी सिग्नल पास होगा. हाई पास फिल्टर सिमिलर टू योर differentiator circuit, but a differentiator circuit means in the particular frequency your signal will be differentiated. That means the low frequency, when you give the low frequency signal to the differentiator circuit, then your signal will be differentiated. But when you give the high frequency signal to the differentiator circuit, there is no change. Both input and output are equal. दोनों का सर्किट जो डिजाइन है वो सेम है, लेकिन तुम कह नहीं सकते कि लो हाई पास फिल्टर इज इक्वल टू द सर्किट. बोथ आर सेम.
Yes, sir. Arrangement is same of components.
Yes. Arrangement is same. Sir. Okay. Any other doubts? If no doubt, then just give an attendance. कुछ डाउट है तो पूछ सकते हो. Give an attendance. मैंने मैनुअल अपलोड कर दिया है सेकेंड एक्सपेरिमेंट. एक्चुअली मैंने मैनुअल अपलोड नहीं किया था. Okay, just all of you give your attendance. ID 1.
Abhishek Gupta present, sir.
तो अटेंडेंस चेक करो, और मिक्सिंग हो गया तो मुझे बोल सकते हो तुम. Two, ID 2.
Present, sir.
3. Adira Sahu. 4.
Present, sir.
5.
Present, sir.
6.
Present, sir.
7. 8.
Present, sir.
9.
Present, sir.
10.
Present, sir.
11.
Present, sir.
12.
Present, sir.
13.
Present, sir.
14.
Present, sir.
15.
15 present, sir.
16.
Present, sir.
17. 18. 18. 19.
Present, sir.
20.
Present, sir.
21. 21. 22.
Present, sir.
23.
Sir, you are actually marking 23 and asking 22. In that case, it was 23.
ओके ठीक है, इसलिए तो मैंने ये अटेंडेंस में दिखा है. और किसका प्रॉब्लम वाले तो बोल सकते. हाँ, 21 प्रेजेंट, एब्सेंट. 22
Present, sir.
23.
Present, sir.
Sir, you again marked 24 and asked 23.
Okay.
Actually, number one for student ID and name. That's
Yes,
Ah,
sir.
yes.
Yes, sir.
Not, this is serial number.
Okay, sir.
This column is serial number. Okay. Now this is your ID and this side is the name.
Okay, sir. Okay.
Okay.
Sorry.
24,
present.
25,
Present, sir.
26,
Present, sir.
27, 27, 28,
Present, sir.
29, 29, 30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
6,
Present, sir.
7, 7, 8,
Present, sir.
39,
Present, sir.
40,
Present, sir.
41,
Present, sir.
42,
Present, sir.
43,
Present, sir.
44,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7,
Present, sir.
48,
Present, sir.
59, 50,
Present, sir.
51, 51, only 50, 52,
Present, sir.
53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
56,
Present, sir.
57.
Excuse me,
Present, sir.
sir.
57.
Wait. हाँ बोलो.
Sir, 37 present.
क्या कर रहे थे तुम?
Sorry, sir.
58,
Present, sir.
59, 59 is done. 60,
Present, sir.
61,
Present, sir.
62, 62, 63,
Present, sir.
64, 64, Sahil, 65,
Present, sir.
66,
Sir,
Present, sir.
sir, I guess Sahil is present. He's raising his hand. I guess his mic is not working.
so this mic is not working, just they write in the chat box. No one write in the chat box. जिसका माइक काम नहीं कर रहा है तो चैट बॉक्स में लिख सकते हैं ना, चैट बॉक्स में लिख सकते हैं. हाँ, व्हाट इज योर आईडी साहिल? नेक्स्ट 67,
Present, sir.
68,
Present, sir.
9,
Present, sir.
70.
Present, sir.
Okay, देखो तुम्हारा टोटल एक्सपेरिमेंट कंप्लीट होने के बाद तुम्हारा लैब एग्जाम होगा, ठीक है. और एट दैट टाइम यू डोंट टेल सर आई एम absent on that lab, that's why I am not presenting this lab or not designing the circuit. Don't tell at that time. Okay, then मैं तुमको बार-बार बोल रहा हूँ, again I will repeat. Those who have not those who have any doubt, then you ask me. ठीक है, अगर कुछ डाउट है तो तुम पूछ सकते हो मुझे.
Sir, Sir, when our offline class would start, will we get an opportunity to do these experiments again in offline, like for practice?
Offline class, actually this is not possible again to repeat this experiment. Maybe one or two classes, that is offline classes, maybe one or two, that is a fundamental class. Actually अभी देखो तुम्हारा सेकंड एक्सपेरिमेंट चल रहा है, देन अनदर जो ब्रांचेस है ना, दे आर ऑलरेडी कंप्लीटेड 3 एक्सपेरिमेंट.
Hello, sir.
हाँ बोलो.
Sir, I was present. Actually, I don't know what happened to my mic.
हाँ ठीक है, आई ऑलरेडी गिवन अटेंडेंस.
Okay, sir. Thank you.
ऑलरेडी गिवन. तुमको ऐसे कुछ मैसेज गया है क्या वो कॉलेज आने के लिए?
No, sir.
Actually, not
Sir,
from the
there is
college,
no.
but the news is there that the Orissa government has allowed from 7th.
Yes. No, Odisha government already declared in the 7th February, all the school colleges are open. Technical university open on the 7th February. देखो हमारा कब खुल रहा है तुम्हारे लिए तो हमको पता नहीं, क्योंकि तुम लोग दूर में हो ना, अभी आने के लिए थोड़ा टाइम लगेगा तुमको. क्या कर रहे हो हमको तो पता नहीं.
Sir, no, we are asking that if we go offline, then those experiments we are performing now on online, will we get a chance to perform it again for before the
First experiment you perform again. That is compulsory. First experiment is compulsory. अगर अरे तुम अभी ये तुम्हारा ऑनलाइन क्लास है ना, जस्ट बट इन द ऑफलाइन क्लास यू जस्ट चेक द हाउ इज द कंपोनेंट.
Yes, sir. If we will not, yes, sir.
हाँ अभी ऑनलाइन में क्या हुआ, ठीक है, जस्ट यू सी द पिक्चर और इमेज, बट फिजिकली यू डोंट नो.
Yes, sir.
अगर जब तुम्हारा ऑफलाइन क्लास होगा तो फर्स्ट एक्सपेरिमेंट तो सभी के लिए अगेन दोबारा रिपीट होगा.
Okay, sir.
वो CRO कैसे, फंक्शन जनरेटर कैसा है, मेजरमेंट कैसे करते हैं, दोबारा वो क्लास कर लेना पड़ेगा.
Okay, sir.
बाकी सब नहीं लेने से चल जाएगा, लेकिन फर्स्ट एक्सपेरिमेंट तो करना ही पड़ेगा. ठीक है. ओके, थैंक यू.
Thank you, sir.
थैंक यू टू ऑल.
Thank you, sir.
Thank you, sir.
ID 29 present, sir. My network issue is occurring.
29.
Yes, sir. 29.
Sir, ID 62 is also present, sir.
62 मैंने ऑलरेडी दे दिया है शायद.
Sir, 29 present.
नहीं 62 प्रेजेंट है.
Yes, sir.
मोनालिसा पंडा 29 है.
Yes, sir. Present.
ओके, थैंक यू.
Thank you, sir.
Thank you, sir.